All right, guys. Moving on to subtraction of matrices today. Again, as I said in the description, it's really a lot like adding matrices. I do want to go through one little thing for you with you before we do this, and then look at maybe one example and release you to go ahead and do this practice. It's going to be pretty easy for you, especially on Monday, but just wanted to at least touch base with you a little bit and let you know what you need to do. So let's look at this first sentence on subtraction of matrices. It says subtraction of matrices is similar to addition of matrices in that the matrices to be subtracted must be the same size. So again, just to review what we talked about on Friday, if you're looking at a 2 by 3 matrix, then in order to perform subtraction of that matrix, the other one must also be like a 2 by 3, okay? And that's just an example. It could be a 3 by 3, 2 by 2, could be anything, 1 by 3. But whatever matrix A, let's say, is, then B must be the same dimensions or it cannot be subtracted. And this actually leads you kind of, to me, a weird direction to be able to do this. It's not really this complicated. So I want to go through an example real quick, much like I did the other day, just so that you kind of get an idea of how to do this and um, how to look at it at both ways, and really take something you've learned before and be able to apply it to what you're doing now. So if you look at this, you got 4, and let's say it's minus x minus 2. You hear my phone ringing back there. We're just going to kind of ignore that right now. All right, 4 minus and x minus 2. Let's think about what we really have to do here, okay? I'm taking 4 and I'm subtracting from it this entire quantity, okay? Which means that I'm going to have to, what I want you to think about is there is a 1 right there, right? So if I'm subtracting this whole quantity from it, that means this subtraction symbol actually applies to everything here, okay? So what I really have to do is I have to distribute this negative through, okay? If you think about that, in order to be able to do this. So what I really have is I have 4, negative 1 times x is minus x, and negative 1 times negative 2 is actually positive 2. And that's what they're trying to tell you over here, but to me, it just looked confusing, okay? So then I'm going to, of course, collect my like terms. I want to have 4 plus 2, which would be 6 minus x, okay? So this would be the final answer for that. But what I wanted you to see is that you have to distribute that negative through, okay? So let's look at a live example, and I think this will make more sense as to what we're talking about. So let's look at number 1 here. And again, first thing, I'm going to look at the size of these two matrices. So I've got 1, 2, 3 rows times 2 columns. So this is a 3 by 2. And here I've got a 3 by 2 as well. So that's the first thing you need to do. Make sure that both of those matrices are the same size in order they can be subtracted. Again, our instruction says when the matrices cannot be subtracted, write MP. So we know there's going to be some that are not going to be able to be subtracted. Okay, so do that first. I don't want you to start going through the process of doing it before you actually figure out what's going on. So if this is a 3 by 2 and we're subtracting a 3 by 2, what size matrix am I going to have? Well, I'm also going to have a 3 by 2. So we'll just go ahead and kind of sketch out my brackets, okay? And I know that's probably harder to do on Cami, but we're kind of dealing with what we've got, right? So again, it's the same exact process. I'm going to start with this element in the top left-hand corner right here, which would be 1, 1. And I'm going to subtract from it 1, 1 over here. But remember, I'm doing subtraction, right? I'm doing subtraction. So 1 minus 3. Well, 1 minus 3 is going to give me a negative 2, right? All right, let's keep going. 2 minus 2 is going to equal 0. Pretty easy so far. If you can do subtraction, you can do this, okay? 6 minus 1. All right, 6 minus 1 is going to give me 5. Here's where, again, it gets tricky when you start throwing some negatives in there. So watch what happens. I've got 0 minus a negative 3. 0 minus a negative 3. Let's just kind of write that out right over here. 0 minus a negative 3, okay? Think about what happens here. We got to keep, change, right? So keep, change. That actually becomes 0 plus 3, or that becomes a positive 3. If you don't think about this, it's kind of like being part of the formula. Remember when we talked about slope and some of these other things, that that this has to be like part of the formula, okay? So 0 minus a negative 3 actually becomes a positive 3. So think about this kind of being like an opposite symbol. it does the opposite of what it should do. So now we have -1 minus 5. -1 minus 5. And if you need to write that out over here, -1 minus 5, to help you to kind of figure out what you need to do, well, -1 minus 5 is actually going to be -6, right? And last but certainly not least, I'm going to take this element right here, and I'm going to subtract this element from it. So I have 4 minus 1, which gives me, again, 3. And this would be my answer for that particular problem. All of these pretty much the same. Again, make sure that you look at your dimensions first, because I bet you're going to have at least one that's going to be not possible. All right. Now what I want you to really think about is right down here, number 7 and number 8. It says perform the proper operation or operations, notice that S right there, on each set of matrices. So what you need to think about here for these particular two problems is your order of operations. Please excuse my dear Aunt Sally, right? You're always going to start with parentheses if there's any. Then you're going to work with exponents, which in this case, I don't really see any of that. We see some matrices here, but no parentheses, no exponents. But then what does it tell us to do? It tells us to do either multiplication or division, right? Those are interchangeable. So multiplication or division, then we do addition and subtraction. So you're really going to have to look at these and see what you need to do first. You notice here I've got some scalar multiplication. I might ought to do that before I do any adding, okay? So I'm not going to tell you much more other than you just got to really think about your order of operations and what needs to happen first, okay? Again, you can use the matrix calculator on these. It will do this, believe it or not. But again, it may take you as long to type it in as it does to actually do it. These two would probably be good candidates, I would say, for that matrix calculator if you want to use that, especially this one that's got half. Which again, we could do this where it's not that difficult, but you would need to do this part first and then that, okay? So hopefully this has been helpful to you. Again, a real short video, but I just wanted to make sure you at least knew what you could expect. Thanks.